Thank you for joining us today. Welcome to the webinar. This is our bi-monthly webinar series that we hold out of, as Anna mentioned, EPA's Office of Research and Development. And this project is actually part of our Safe and Sustainable Water Resources Research Program, which is EPA's National Water Research Program. So today, of course, as you know, will be Dr. Kevin Oshima will be presenting on the Village Blue project, but before we get started, I'm going to just go over a couple things before I turn it over to Dr. Oshima. So if you have any, Anna will also be on the line today. If you have any issues with audio, you can't see your screen, in your navigation bar, there is a chat box and a questions box. So if anything happens during the webinar, just let us know there. And there's also a number here in case if you need to call for support. Also on your navigation bar, you'll see there's a handouts drop down. We did provide a copy of this presentation for you to download and keep there. At any point, we are going to try to have a short Q&A session at the end. I can't guarantee that we can get to that many questions today. We do have a very large attendance. We'll try to get to as many questions as possible. So if you have any questions at all during the webinar for Dr. Oshima, go ahead and type those in the questions box and we'll get to those at the end of his presentation. If we are not able to get to all the questions, Dr. Oshima can follow up with you after the webinar via email. Okay, so today's webinar is on the Village Blue project, which was actually initiated by EPA and USGS, the US Geological Survey, and it was initiated to increase public awareness about local water quality, and that's in the Baltimore Harbor and Chesapeake Bay area. So Dr. Oshima is presenting today. He is the Associate Director for Science with EPA's National Exposure Research Laboratory here in Cincinnati. And although Dr. Oshima is presenting today, there are several other contributors to this project here at EPA, including, as you see here, Dr. Gary Norris, Dr. Alan Lindquist, Alexis Len, and Samantha Rachko. So with that, I'm going to go ahead and let Dr. Oshima get started, and I'll turn it over to you.
Great, thank you, Michelle. Can you hear me?
I can, thanks.
Okay, and you can see my screen, I think.
We're getting up right now. And actually, while Dr. Oshima is getting to his first slide, I can see your screen. If you just joined us, we had a poll about attendees in the room. If you have more than one person in the room with you, if you could please put that number in the questions box for us, that really helps us with tracking how many people we're reaching with these webinars. And also, we are providing, I did forget to mention, a certificate of attendance if you would like one for this webinar. If you have more than one person in the room with you who would also like a certificate, please just type their name in the questions box and we'll make sure they get one as well. And your slides look good.
Okay, thank you. So I'm going to go ahead and start. So the first slide here is kind of an outline of the presentation. I'm going to talk about the challenges with using water sensors, the background of the Village Blue project and the goals, description of the sensors and examples of data analysis, research objectives, tour the website. So you guys are going to get a chance, if you want, you'll be able to click on the website and actually see it in real time. The website is live. For those of you that aren't on the computer, I'll have it also on the screen so you can follow with what is on my screen. We'll just have a description of the outreach activities and then finally talk about project impacts and timeline. Okay. So, so I'm going to talk a little bit about, oh, hold on a second, let's see. Okay, sorry, I'm having a little bit of an issue with my own control here. So I'm going to talk a little bit about the challenges associated with sensors. So water sensors as a technology is not new, but there are capabilities and technologies that are advancing. And water sensors certainly have the potential to answer science questions that EPA and others are trying to address, and also represents opportunities for community outreach. learning concepts that may be similar to the agency questions, but also information that may be of interest to stakeholders. So this sort of forms the genesis of the Village Blue project. So I'm going to talk a little bit about some of the challenges. So real-time sensors are just what they do. They provide information in real time. So one of the questions is, how do you quality assure real-time data sensors that are in the field? So that's one of the things that this project is going to try to address. How to more fully realize the potential of using real-time sensors to understand processes that influence water quality in watersheds. So just because you have real-time data, that does not automatically mean that it's useful or better. So one of the things that we're going to be spending a fair amount of time on is looking at the data and saying, well, in what ways does it improve the data set, and how can that benefit us in terms of ScienceCast? We're going to more fully take advantage of the innovative approaches for collaborating with community partners on visualizing and using water sensor real-time water quality data. So the visualization, so I'll take you to the website and you'll kind of get a chance to see that visualization, what it looks like, and the educational component of helping to have a broader audience in terms of what the water quality advantages are when you're using real-time sensors. Improve the communication of water sensor-based water quality information by working with federal, state, and local organizations. So this is a little bit of it's a combination of science objectives, and tied to it is this outreach and working with stakeholders and other state and local organizations. So the Village Blue demonstration project. So the EPA and the US Geological Survey have initiated this Village Blue research project to provide real-time water quality monitoring data for the Baltimore community and increase public awareness about local water quality in Baltimore Harbor and the Chesapeake Bay. This is a demonstration project that complements some of the work that's ongoing in that area. So the inner harbor of Baltimore is a highly urbanized, impacted water body. So there's a lot of local and state interest in that, in the inner harbor. The local community is also wanting to make the Baltimore Harbor swimmable and fishable by the 2020. So the USGS has set up a new monitoring system upstream of the Waterfront Partnership Inner Harbor water wheel. And what you see in the picture is the water wheel, which is kind of cool. It has the ability to basically pick up trash, plastics, and other things that are floating debris, and pick it up in a water wheel and dump it in a dumpster. And that is a very highly observed website and other public outreach activities that the partnership is doing. And so our sensor array is located just a little upstream of that. So the Village Blue project goals. So characterize the performance of water sensors, look at the robustness, maintenance, transition of data from provisional to approved. So the way that sensor data is collected, initially is collected is considered provisional, meaning it still requires some additional QA. And then it goes through a process that then transitions from provisional to approved, which basically means it's the final data set and it's been fully QA'd. USGS is really the lead in terms of this activity. Analyze real-time water quality and weather data to develop models for community outreach and to inform basic understanding of important water quality parameters using statistical and process models. Explore approaches to use sensor data to increase public awareness of the impacts of water quality on human and ecosystem health. So that's the community outreach component. Create an EPA website that provides additional visualization tools for sensor and weather data and background interpretive information on sensors, and how a guide or and a how-to guide so other communities across the U.S. can install their own Village Blue stations. And so that's another sort of component of this demonstration project, to be able to transport the understanding and technology to other locations across the United States. develop communication outreach documents on how to develop similar projects in other communities. And finally, evaluate the impact of community outreach activities. So the Village Blue team is a multidisciplinary research and outreach project. It involves the USGS folks who are very adept at sensors in terms of deployment and maintenance and QA. The EPA Office of Research and Development, which has on this project microbiologists, engineers, modelers, and community outreach folks, as well as a communications team. And the EPA Region 3, which includes communications and outreach. And also the Blue Water Baltimore organization that helped us with sample collection and analysis of fecal indicator bacteria. And so on the right-hand side, it talks about some of the outreach activities with the Baltimore Aquarium, the Waterfront Partnership, Blue Water Baltimore, Baltimore Urban Waters Partnership, and the City of Baltimore. So this is a picture of the actual site where the sensors have been deployed. So as I mentioned before, this is in the inner harbor of Baltimore. And so the dot over here is hard to see, but the location is right about here. And then it's close proximity to the Baltimore Aquarium for anybody who's been in the sort of the inner harbor waterfront. The Baltimore Aquarium is right there. So is the Science Center. So there's a lot of what I would call it tourism and other business activities along the waterfront. Okay, so the real-time water quality data. So what kinds of sensor information are on the sonde? So the monitoring data is at the Jones Falls River. So this is sort of at the interface between Jones Falls River, which is basically a fairly urbanized small stream that goes through the heart of that part of the inner harbor. And so this sensor array is picking up a number of different kinds of water quality parameters, such as conductivity, dissolved oxygen, nitrate, pH, temperature, turbidity, and then there's also wave height and flow direction velocity. So that's keeping a sense of which direction is the water flow going and what kind of velocity is that water moving at. We also had a chlorophyll and phycocyanin, which is algal sensors that look at algal blooms, and it was deployed for a while, but it is currently offline. And we're also pulling in NOAA meteorological data on precipitation, as well as radar information. So this is some pictures of what the sonde looks like. So this is the way that the sonde is supported. It is at the outfall, so there's actually two, and I'll show a diagram in a second, but there's actually two sets of sondes, or sets of sensors, one that is primarily in the freshwater component and one that's sensing within the marine component. So we're actually being able to track what's actually feeding into the Jones Falls or into the inner harbor from the Jones Falls River. So this is the actual picture of the sensor array. On the right is the tuna nitrate sensor, and on the left side of that, on the bottom there, is the EXO basic sensor array, which contains the basic turbidity, pH, temperature, a suite of water quality parameters. This is a picture looking down towards the inner harbor. So you can see on the left side over here, this is where the sonde is located, and you can see downstream of that is that trash reel that's picking up floating debris as it passes. Oh, also on this link here at the bottom is the actual location where the USGS is streaming live in real time at the NWIS site, the sensor array data that's being collected. And so if you click that link, you can actually go to that site and you can see the data as well. This is a depiction schematic of the actual sonde and how it's being configured within the Jones Falls River. So as I mentioned, there's two suites of sensors. There's one suite that is really sensing the freshwater column, and then there's a lower probe that's sensing the marine column. And by looking at both of those, we can kind of look at, well, what's coming into the inner harbor through the freshwater layer, and then how is that potentially impacting the marine layer? How do those two layers of water interact with each other? So I'm going to give a couple of examples of some of the ways that, just to give you kind of a snippet of some of the ways that the data can be looked at. So this is some compilation of various sensor data within a specific time period. And you can see both the conductivity, so of the lower sensor, so that'll be conductivity within the marine layer. And in red is the conductivity within the freshwater. And as you would expect, there's going to be greater conductivity in the marine layer. But what's happening is there's been a major rainfall event. And we know that because these sort of bluish dots are representing precipitation during that same period of time. And so there's been an influx of precipitation. We also know that because the velocity is also indicating that there's a change and shift upward in velocity. The other thing, so what you're seeing is in the Jones Falls, as a result of rainfall, there's going to be a much bigger swath of fresh water coming in. And so the bottom layer, which is the higher conductivity in dark blue, is being basically displaced because of the influx of fresh water. So that's one example of how water quality can change, in this case, looking at conductivity from a rain event. So this next slide is looking at data in sort of a different way, and this one is more focused on rainfall on nitrogen and in the inner harbor. So here we're looking at the nitrogen sensor, which is sensing in the freshwater layer. There's turbidity in red of the upper layer. And so what you see is that with a rainfall event, you typically, and this is pretty standard, you'll see an increase in turbidity because of all the stormwater runoff. You'll also see a decrease in this case of nitrogen, which at least in terms of just concentration, because of the influx of volume, then the nitrogen levels will go down. But you're also seeing, and this is what the circle in black is showing, is that there's a spike in the nitrogen level towards the sort of that's offset by the turbidity. So there seems to be some sort of additional phenomenon going on, and that sort of is displayed again here on the right by looking at the discharge volume and then looking at the nitrogen levels. So one of the things that this isn't showing that we would want to show is sort of not just is it the concentration, but the volume's increasing. So we would want to account for the volume increase. And when you do that, it's quite possible that the total nitrogen levels will actually increase. So, so this is one way to kind of look at how nitrogen is influenced by rainfall to understand sort of the impact of nitrogen within the inner harbor. And we can compare that between this example, which is a rain event, to non-rain event conditions. Okay, so focus areas for research. So as I mentioned, water sensors are a relatively new technology, and so there's a need for developing quality assurance, quality control, QA/QC approaches, how to manage that rather large data set, characterizing the robustness of the deployed sensors in marine and freshwater environments. In other words, that those conditions are changing, and so you'd want your sensors to be robust to changing environmental conditions. And so oftentimes it's been our experience that as we talk about water sensors, one of the places where we see a lot of questions and interest is in this first bullet, which is sort of understanding how to quality assure real-time data. application of software tools to model water quality parameters using sensor data, the use of EPA modeling tools such as Canary and Virtual Beach. So Canary is a software package that was originally done or developed to evaluate drinking water distribution systems, especially looking at event detection, meaning when something in the system has changed, Canary can pick that up. So now we're asking the question, can Canary be applied to something like this, which is ambient water quality conditions, and make note when, say, turbidity or dissolved oxygen or other parameters change and make us aware of when those changes occur. Virtual Beach is a software package that was developed for the prediction of microbial water quality, specifically for beach managers. So to look and see based on weather and water quality parameters, can you actually predict when microbial water quality may be adversely affected? So we're using this weather and water quality array to see if Virtual Beach could potentially be applied to this real-time data. Working with federal, state, and other organizations to improve or establish community outreach based on sensor applications. Contributing to the development of a sensor network in the Chesapeake Bay and the Baltimore Inner Harbor, working with collaborators such as USGS, Maryland DNR, and of course within the EPA. So now I'm going to talk about the Village Blue data and the website. So EPA and USGS display the real-time data on the National Water Information System, which I showed you the link to a few minutes ago, and which also links to the Village Blue website. And so the landing page provides additional context about Village Blue, interpretation of sensor data, frequently asked questions, and a link to the Village Blue application. We'll go into that in a second. The monitoring application provides additional visualization of sensor data that helps users interpret sensor information. And there's a link for that as well. And then there's also a link for the fact sheet. So providing visualization information. So involving communications, this involves the communications team, the Office of Research and Development, on developing approaches for integrating landing page and the application website. So one of the things that this project is kind of like a guinea pig is how do we, as EPA, present this information in the website and going through the process. So developing the application website, and providing and developing a platform that can be transferred and customized for other water sensor projects. So what we've laid down here, we think is sort of a platform that can be adapted so that other folks that are using sensor data can basically use the framework that the website provides and develop their own real-time data in a fairly much easier way than we did the first time going through it. Baltimore partner review of the preliminary website. So when we stood up the website, we asked our partners in the Baltimore area to look at it, provide comments, tell us what they liked, what they didn't like, and we tried to incorporate that within the website. Explore opportunities to have Village Blue support developing the Canary event detection data analysis tool for interoperable watershed network, which has Village Blue, state, and USGS data. So I'm going to now transfer over to the website. So you have a couple options. The folks on the line, you can either just follow along, and I'll go over to it, or if you have access to a computer and you want to kind of see for yourself, you can do that as well. So let me just click over to that. So I think you guys now, for the folks that are are viewing, so this is now the landing page for the Village Blue. It has a lot of the same information that I just went through. So this is the landing page. So ideally, this is what people will see the first time. You know, when they click onto it, so it gives some background information. talks about what data are being collected, and if you click this, it'll provide additional information. And so there's a series, how are data being collected, what will Village Blue accomplish, what are EPA's partners, and then there's some linkages to some other documents like the Village Blue frequently asked questions, the fact sheet, news releases, etc. So, but if you scroll back towards the top, if I click Explore the Data, it'll go to the actual application page. So this is where the data is actually displayed. And so in this box on the right, it actually tells you right now what the sensors are picking up. And then it indicates that this is a collaboration between the EPA and USGS. It provides a lot of the same visualization information that you saw earlier on this presentation. It has additional information, learn about Village Blue water sensors, pictures of the sun, but also you can look at and click, for example, gauge height, and it'll tell you something about what the gauge height sensor is doing. Stream velocity, likewise. And so you can click each of these, and it'll tell you something about what those sensors are reading. And then there's a diagram again of the sensor deployment. And then if you scroll further down, it now starts to talk about, or you now see the actual sensor information. So this is being downloaded from the NLIS site at USGS and beamed into the application page, and you can see that there are some directions here on how to use it. Use plus minus controls to expand or shrink the plots. And so here's the plus or minus, and I'm going to just click plus. And so you can see how the y-axis is now being stretched, expanded, and you can see differences a little bit more clearly. You can use the checkboxes here to either deselect specific sensor information if you're not interested in it, and just select the ones that you are interested in. You can hover over it, and you can see how it kind of just screens through all the different parameters. So you can look at the various parameters at the same time and kind of see what's going on between the parameters. You can also compact the area. I won't do it here, but you can compact the area so you can focus on a certain period of time. But also you have options for, as it's clicked now, 7-day, but you can also go, for example, to 30-day. It'll take a minute to kick in, I think. Taking a little bit longer than I normally see it. Could be that there's folks on here and it's slowing it down a little bit. There it goes. So now this is now displaying it in the 30-day increment. And so I'm just kind of going to go through this. You can see the Maryland Science Center precipitation. So this is the rainfall that's being collected at the Science Center, which you saw on the map is just a hop, skip, and a jump away from where the sensor array is located. But having said that, that's rainfall at the Science Center. There may be other rainfall that's occurring upstream of the watershed, and so we will be pulling in other precipitation information, not just the Maryland Science Center gauge. So here's the Jones Fall gauge height. Kind of since this is in a marine setting, you'll have tides going in, and this is reflecting that. Stream velocity, so that's sort of the amount of water that's flowing through at the site of the sensors. Turbidity, so we have turbidity both in the upper and lower sensor array, and so that's being streamed here both at the same time. And then salinity, which we talked a little bit about, so the red is the marine layer and fresh is the blue. And then dissolved oxygen, and then the nitrate, temperature, pH. And then it talks about a little bit of background on some of the partners that we are working with. So that is that is sort of a summary of the application page, which went live right before Christmas of I guess now last year. So it hasn't been, it's still fairly new and hasn't been live for that long yet. So now I'm going to go back to the presentation. Let's see. So moving on, we're going to talk about the outreach activities. So let's find. Skip the slide, yeah. So outreach activities. So the objectives: working with stakeholders, develop outreach opportunities to highlight how sensor data can be used to inform inner harbor water quality. So this is a community that is really values their inner harbor. And so we have a really enthusiastic community that we've been lucky enough to partner with. So that includes the Baltimore National Aquarium, the Waterfront Partnership, the Baltimore Urban Waters Partnership. And again, part of the outreach activities is, should another community somewhere else want to kind of use the Village Blue as sort of a way to show them how to maybe transfer this over to another location, the other part of the outreach activities is to provide the documents to help them with that process. So here's an example, hot off of the presses, because we just got this yesterday. So this is with the Waterfront Partnership. So they have been very interested in trying to take elements of what is live streaming and build a three-dimensional structure that will help sort of interpret water quality parameters that people can view and see and come up with something that, you know, kind of helps them interpret what the sensors are indicating. So this picture over here is a prototype of what that might look like. And so what you see is a heart shape, which will illuminate, which I'll show you in a second, and then cut out underneath that is a sort of a image of the inner harbor. So this could be as an educational tool, and I'm going to show you an image or a video here that shows kind of how it works. So this is kind of tied into dissolved oxygen. So when dissolved oxygen is in the healthy range, it's going to be green, and then as it deteriorates, then the color may change. And so this is kind of showing one way to show interpretive information on what the sensors are collecting. And the Waterfront Partnership is very interested and enthusiastic about trying to utilize the sensor array for that purpose. So we're also likely to roll this out at a public art event at the Maryland Institute College of Art. So so that's one example of an outreach activity. So the other things we're doing is developing storyboards, a way to communicate sort of what the sensor array information is conveying. So this is sort of a diagram indicating that the Jones Falls River is impacted by whatever that watershed is. And this is a fairly urbanized area, so you have runoff from various sources. And that is all feeding into the Jones Falls River, and we have a sensor array kind of at the mouth where it enters the bay. So it provides an opportunity for education on various issues related to water quality and the utilization of sensor technology. So it can highlight critical environmental and public health issues. So ideas include some of the things that we're talking about is what happens when it rains. So rain events have a dramatic impact on watersheds and the stormwater that's being collected. And so it's a characterization of the kinds of contaminants and other things that potentially are within that watershed, and all that is being collected and delivered into the inner harbor. So the impact of the outfall on inner harbor water quality. Or another way to look at it is, what happens when it rains? You have stormwater runoff, sanitary sewer overflows, which is something that happens within the inner harbor. Trash from the runoff is increased when you have a rainfall event. The river changes in physical characteristics like velocity, height, or rainfall. The chemical constituents like turbidity, salinity, temperature, DO, and nitrate can change. And so the question is, how does that impact the inner harbor, and how does that impact potentially the community? So we can show rain events in this process. We can develop hands-on activity. We can assess the impact of the activity on participants, provide real-time water quality and other information to the community to better understand what the impacts of the inner harbor water quality is. Some other examples of public engagement: engage in public data gathering events. We think that we will partner with the aquarium and with some of their activities and sort of draw them an opportunity to talk about sensors and water quality in the harbor in that environment. So creates opportunities to convey that information to the community, and also create an opportunity to demonstrate public access to real-time data. So these are some of the kinds of questions that we are considering. Data being delivered as information to the public and absorbed, resonates and educates at the appropriate level. So one of the things that we're doing is there's a separate part of this project that really focuses on what the impact is. So does water quality information stimulate public action, participation, or the interest to obtain additional information? Are there ways to measure and document success in any of the above? So does this kind of community outreach that we are using sensor-based information, can we actually measure what kind of impact that has at the community level? So Village Blue impacts. Provide additional guidance on quality assurance and the maintenance of sensors, provide performance characteristics of sensors, modeling of results, develop community-friendly web access, visualization of Village Blue sensors, implementation of outreach to increase awareness and the understanding of water quality in the inner harbor, and the application of water sensor information more broadly. Assess the effectiveness of outreach, documentation or how-to guides to assist other stakeholders on the utilization of water sensors. Here's kind of the timeline. As I mentioned, the website went live in December. So at the research end of things, we're just now gearing up on ways to look at the information, the modeling activity. So there'll be much more to come as time goes on as to what kinds of things we're able to document through the data that we're collecting. The other thing I would mention too is the landing page and the application will continually evolve. We will add additional information to the landing page and potentially add additional items like canary information on the application page as well, or the virtual beach modeling efforts that we are beginning to engage in. Continue to work with partners to support outreach activities. We think that that's really going to be gearing up in fiscal year 18. Measure the impacts of outreach activities. This would be more of a fiscal 18 activity. Research products, so findings of QA/QC, the robustness of deployed sensors in marine and freshwater environments, application of software tools to model water quality parameters, evaluate sensor data versus batch. So one question that we have is, so you have this rich data set versus the traditional, you go out to the site, you collect water samples, you bring it back to the lab and you analyze it, and that's done on a much more sporadic basis. So with the greater density of information, how does that improve or impact our ability to model? we think it should improve it, but to what degree does it do that? And then apply this information to for scientific and outreach needs. So, and then finally, the effectiveness of community outreach based on sensor applications. So one of the things that we're very interested in is feedback. So very interested in the questions that the folks have on this webinar today. Interested in things like suggestions for other outreach narratives, interest in Village Blue at other locations. We're starting to get inquiries from different places around the country, opportunities for collaborations, suggestions for outreach or partnerships. We welcome comments and suggestions to a Village Blue website. So one thing that I want to mention is that you can, if you click on the website, there is a link so that you can send an email if you have questions or comments or anything you want to state, that we will receive that and we'll do our best to respond to them. So that concludes the presentation.